1989. That's the year Cummins and Dodge teamed up. Dodge had previously experimented with selling diesel pickup trucks with Mitsubishi engines, and while the Mitsubishi 6DR5 that you could find in the Dodge D150 and D250 was a good engine in its own right, it was only a 4-liter and had very limited power production, which ultimately led to it failing. Because of stiff competition between GM and Ford, Dodge needed something to kick their sales into high gear, which was the whole point behind offering a Cummins engine in their trucks. Today, more than 80% of Ram 2500 trucks sold use a Cummins power plant, and that number is even higher for the 3500 models. The first engine in their partnership was the 5.9-liter 12-valve engine, and that was followed up about a decade later with the 24-valve 5.9 engine. And while diesel guys will never fully agree on who has the best engine, whether it's GM, Dodge, or Ford, the general consensus is that the 12-valve 5.9-liter is the best light-duty pickup truck engine ever. But of course, no engine is perfect, so let's take a look at everything wrong with the 5.9-liter. We'll look at everything wrong with the 12-valve and the 24-valve and how to fix it. When the 6BT Cummins was debuted in 1989, it was a game changer. And even though it was stuffed into a very outdated Dodge chassis, it gave the Ram trucks a new foothold in the pickup truck market. The 6BT packed a turbo, direct injection, and a whopping 400 pound-feet of torque, which exceeded anything Ford and GM were offering at the time with their V8 diesel engines. With the new Cummins engine in their Ram trucks, Dodge saw an increase in sales in their Ram lineup for the first time since 1981. The original 12-valve Cummins predates the P-pump version, but it definitely set the tone in the diesel truck segment for years to come in terms of power, fuel efficiency, long-term durability, and more. In the first year, the Cummins engine option was equipped on over 18,000 trucks, which is about double what Chrysler had initially expected. One of the nice features of the 5.9-liter Cummins is the gear-driven camshaft system, which today is pretty much standard on all diesel engines except for maybe a handful of engines like the GM 3-liter Duramax, but for the most part, a gear-driven camshaft system is pretty standardized, and that's where you'll actually find the very first problem on the 5.9-liter Cummins, which is the killer dowel pin, or KDP. One of the funniest parts about the KDP issue is that it's not even a mechanical part of the engine. It's quite literally a teeny tiny little metal dowel inserted into the front of the engine block that is used to align the front gear housing during initial assembly. As I mentioned a moment ago, it's located near the gear train on the front of the engine, and more specifically, it's located above the camshaft gear and just to the left of the injection pump gear. In any other engine location, this little pin probably wouldn't cause too much of an issue, but because of specifically where it is, it can cause literal catastrophic engine failure. What happens is that over many thousands of miles and drive hours, heat cycles, and vibration, that pin can eventually wiggle itself out. In the ideal scenario, when the pin wiggles out, it'll possibly bounce off of a few things and then land at the bottom of the front cover, which then it'll hopefully just settle at the bottom of the oil pan. Unfortunately, that ideal situation doesn't always happen. And the flip side of the coin is the pin falling out and getting lodged between the cam and injection pump gear. If this worst case scenario occurs, it can cause a chain reaction of the valves and the pistons violently meeting together, and ultimately ending your engine's life. In some situations, the result of this is repairable, but in some other situations, it can literally be the end of the engine and even the cylinder block itself. Luckily, Cummins and Dodge did figure this issue out relatively quickly, so it's not something that you really see on the 24-valve. You can see it on some of them, but definitely not all of them. The most common years where you see this problem a lot is on the 1994 to 1998 model year trucks, which is the engine with the Bosch P7100 pump. Supposedly, the P7100 pump models have different harmonics compared to the earlier models with the VE44 rotary injection pump, but that being said, it's still present on the earlier engine. It's just supposedly less common. And because of how this issue occurs at random, with miles, hours, heat cycles, and vibration eventually causing it to wiggle loose, there's no predicting this problem, which means that any 5.9-liter Cummins from 1989 to 2002 is basically a ticking time bomb. That is, unless you install a simple solution to keep that dowel pin in place. This is known as a KDP prevention kit, or a KDP disaster prevention kit, and it's basically just a little piece of metal that helps hold that dowel pin in place, and that plate is held in by the bolt right next to the dowel pin itself. These types of kits are relatively inexpensive, but fairly labor intensive, as it requires removal of the front cover, which really isn't that bad if you have the tools to do it, but it can certainly be a daunting task for somebody who's new to working on their own truck. Moving away from the killer dowel pin, let's take a look at the next two issues that you'll find on the 24-valve engine, which is the VP44 injection pump and the lift pump. Starting with the first problem, we have the Bosch VP44 injection pump, and because of the fact that the 12 valve was mechanically injected and the 24 valve is electronically injected, the injection pumps are quite a bit different. Where the 12 valve injection pump was basically known for being bulletproof and was hard to kill even if you were quite literally trying to kill it, the VP44 is known for having quite a few weak areas that can cause the entire thing to fail. And I don't mean to say that in a negative way, because the VP44 injection pump has its own pros in its own right, but those little issues need to be fixed before you can really consider it a good injection pump. Because we all love throwing shade at the EPA, they're partially to blame for the VP44 being added to the 5.9 liter, as stricter emission standards are what ultimately forced Cummins to switch the 5.9 to electronic injection. Okay, enough complaining about the EPA. The majority of the issues with the VP44 can actually be tacked to the PSG, which is the computer that you'll find on top of the injection pump that controls the whole thing. And similar to the dowel pin problem, with a lot of miles, running hours, heat cycles, and vibration, issues with the PSG can pop up. Most notably, the soldering on the PSG circuit board can create issues with electrical signals, which can then result in a handful of issues, such as long cranking when trying to start an already hot 5.9 engine. Past the PSG issues, there are plenty of examples of the rotor seizing in the distributor part of the VP44 pump. This normally happens from surface damage due to poor deburring during manufacturing. When the rotor seizes up, it'll break the drive plate, which then leaves the VP44's input shaft spinning, but no pressurized fuel making its way to the injectors, which means if this happens, your truck will immediately shut off and not turn back on. That takes us to another part of the VP44, which is the diaphragm located on the distributor head inlet. This supplies fuel to the bores of the distributor shaft, and unfortunately, it's a fairly common failing point on the earlier VP44 pumps due to its poor material that would crack with time and miles. Luckily, this particular issue in the VP44 doesn't affect the later year models, as the diaphragm was reinforced to prevent this issue entirely. That takes us to the second issue with the VP44, and that's actually not even the pump itself, it's the lift pump. And the lift pump is responsible for supplying the VP44 injection pump with a steady flow of fuel, and that fuel is used as lubrication and as cooling for the VP44 injection pump. So if your lift pump starts to fail, it can starve out your VP44 injection pump, and then that can cause a whole chain of issues. Unfortunately, lift pump failure is actually fairly common on the 24 valve Cummins, at least until they introduce the common rail version. The standard lift pump that you'll find on the 24 valve is a self-priming electric Carter lift pump. But oddly enough, it's mounted directly to the engine block, and once again, miles, hours, heat, and vibration can cause it to fail prematurely. This was made even worse by the factory fix for the problem, which was to replace that aforementioned lift pump on the engine block with an in-tank lift pump, which ultimately didn't provide the fuel pressure needed to keep the VP44 injection pump happy. Luckily, the fix for all of this is actually pretty simple, and that's just to install an aftermarket lift pump. Some of the aftermarket lift pumps from FuelFab, FASS, or AirDog have been proven to be capable of delivering adequate fuel pressure as compared to the original Carter electric pump or the in-tank pump. Plus, if you're talking about a non-stock 5.9 Cummins, you'll want a high-flow lift pump in the first place. Otherwise, you'll run into even more issues with the VP44 injection pump being starved out. That being said, if you are on a totally stock 5.9 liter with a stock lift pump, a good way to actually measure your lift pump and make sure that it's working effectively is by installing a fuel pressure gauge, and this will let you know basically how much fuel pressure is coming to your VP44 injection pump. With that in-tank pump, you'll often see around 5 psi, but really to keep the VP44 injection pump happy, you're going to want something closer to 10 to 15 psi. And that takes us to the next fatal flaw of the 24 valve Cummins, and that is the number 53 block. Cummins had multiple companies casting their engine blocks, and one of those was a Brazilian company known as Tupi, who cast approximately 100,000 engine blocks. The only issue is that the Tupi cast blocks have thinner water jacket walls as compared to earlier and later 5.9 liter engine blocks, which ultimately makes these blocks very susceptible to cracking, which then leads to coolant leaking and could quickly result in your engine overheating, especially in a high load situation such as towing. While the issue can theoretically happen anywhere on the water jacket walls, it's most common to occur on the passenger side below the freeze plugs. If your engine ends up cracking, there is a band-aid fix known as stitching, where a machine shop will drill a hole at each end of the crack in order to stop it. However, this is really more of a sketchy band-aid than a real fix, with the only real fix literally being an entirely new engine block, which, as you can imagine, is expensive to buy and also extremely expensive on labor. Because of this, people who are looking to buy a Cummins powered truck typically avoid anything with the 53 block like the plague, and luckily that's actually easy to do because it's really easy to identify one of these blocks by the large 53 that you'll find on the driver's side front of the engine block near the injection pump. And that brings me to my last point, which actually takes us outside of the scope of the 5.9 liter engine itself and to the transmission. And you might have already heard that Dodge transmissions are fairly bad, and there's no lying, they are kind of bad. But more specifically, let's take a look at the 47RE, which is the transmission that you could find in the 1994 to 2002 5.9 liter Dodge trucks. Problems with this transmission range from getting stuck in gear, the torque converter failing to lock, hard shifts, and so much more. And frankly, a lot of the issues surrounding this transmission are simply due to the fact that its components, such as the shafts, clutches, and converters, are all much smaller than they are on competing transmissions from GM and Ford trucks. While GM and Ford use freshly designed transmissions for their trucks, the 47RE reuses an old design, including the use of bands to shift gears instead of using clutch packs like other modern diesel transmissions. Really, the 47RE was out of date the second that it came out, and that, combined with the use of really small components, spells out disaster. Starting with the main culprit for the 47RE's poor performance, we have the low pressure line, which is what actuates the bands in the transmission and simply doesn't have enough pressure in stock form to hold any decent amount of power. A stock unit will only hold around 100 psi of fluid pressure, but with an upgraded valve body, that can be closer to 250 psi, which will massively improve the amount of power that the transmission can hold. And then there's the problems with the valve body pressure solenoid, which often results in the truck getting stuck in first gear. The solenoid works by energizing and de-energizing to govern pressure, and the transducer sends info back to the ECU on fluid pressure and temperature. The issue is when the transducer fails and sends the wrong info to the ECU, which then results in low pressure and the transmission being able to shift up. The solenoid can also fail and produce incorrect amounts of pressure, which can then leave the truck stuck in third gear. Then the transmission bands also create even more issues. For example, the band on the front planetary gear set can become loose, and then that causes issues with shifting from first to second and then second to third as well. To put it really simply, the bands inside of the 47RE are weak and very often prematurely wear out and can mess up shifting. On top of all of this, the really poor electronics and the components being too small, you can see why the Dodge 47RE transmission is basically a piece of poop, and it is literally the weakest point on a 5.9 liter Dodge powered truck. The manual transmissions, on the other hand, are not nearly as bad, so if you get the chance to buy a 5.9 liter truck, you might want to lean towards a manual trans for it. And without a doubt, the 5.9 liter Cummins is the best light-duty diesel engine ever. I don't care what you say, it's absolutely more reliable than any GM Duramax or Ford Power Stroke. But to be fair, all older pre-emissions trucks are pretty reliable, but the 5.9 is undoubtedly the most reliable, with the 7.3 Power Stroke and the LB7 Duramax coming up in a close second and third. That being said, the 5.9 liter is a pretty basic and old school engine, so if you're looking for anything that's clean or quiet and that doesn't leak oil, the 5.9 is probably not the way to go. But I don't think that's an issue because I don't think most people who are buying a 5.9 liter Cummins Dodge truck are looking for something clean, quiet, and efficient. And although it does have some minor issues, once the killer dowel pin is dealt with, it's really a fantastic engine that's super, super reliable. And other than being backed up by a kind of garbage automatic transmission, it is undoubtedly the best light-duty diesel truck out there. Besides the issues that I mentioned in this video and a couple of other really small issues such as it just leaking a lot of oil, there's really not that much wrong with this engine at all. And honestly, most of the issues are on the 24 valve engine and not the earlier 12 valve engine. Where the 12 valve had mechanical injection, it was super duper reliable. The 24 valve brought in that electronic injection and that brought with it some issues. If you guys like this video, be sure to smash the thumbs up button because it really helps me out. Get subscribed so you don't miss out on future videos. Drop a comment down below. Let me know what you think about this video and what you want to see in the future. And I'll see you guys in the next one.